Okay, just real quick. I feel like I didn't answer a pretty vital question in that last video, and it is why are there asymptotes in the first place? Like, why is there a part of the graph that doesn't exist? So let me go through that just quickly. Let's hold on. That's terrible. Stop it, please. Okay, let's suppose that's my hyperbola. Why can't my graph touch this? Why can't I do that? Okay, let's identify why. And it comes down, let's just go 1 on x. So there's my graph. Why doesn't it have an x-intercept? So why doesn't it have an x-intercept? Let's actually try and find it. My x-intercept. Let's move that over there. That means I have to make y equals 0. Now when I do that, I've got 0 equals 1 on x. Now what on earth would I have to have my x value to be for my output to equal 0? And the answer is, it's kind of impossible. If I put a 0 in there, it's going to be undefined. If I put a 1 in there, it's going to be 1. If I put literally any other number in there, it's never ever going to equal 0. And even if I did that, if I multiply both sides by x, then I end up with the statement that 0 equals 1, and I'll pretty much break mathematics. So that's why there's no x-intercept. Let me now show you why there's no y-intercept, and this one's a little bit more obvious. If I make x equals 0, that's basically going, okay, y equals 1 on 0, and if you type that into the calculator, I'm sure you've done that before, or asked Siri, that's kind of not possible either. So that's also undefined. Now, when we start moving things left and right, things kind of get a bit more interesting. So if I have the graph, look, suppose I move up, did I just say left and right? I hope so. Let's suppose I've got my left and right graph. I'm not going to draw a dotted line. Let's just have that for the time being. Now let's suppose this cuts at, or that asymptote is x equals 3. That means my function, or sorry, my graph is going to be y equals 1 on x minus 3. Okay, so that's the corresponding graph. That's this graph. All it is my original move to the right 3. So move to the right 3. Now, have a think about this. This graph doesn't exist when this bottom part equals 0. So the same argument here, the reason that we can't put a 0 in there is because it breaks. So that means I can't have x equals 0. Now x equals 0 is this line, which is the intercept. Now I'm saying with this, I can't have x equals 3. What happens when you put 3 in there? Well, when you put 3 in there, this thing breaks and ends up being 1 over 0. So pretty much your asymptote is going to be when this thing, the bottom, and the denominator, equals 0. So there's an easy way of drawing your asymptotes, and it's, okay, I'll just let x minus 3 equal 0. I know that that's not possible. So what I can do is write this. I know that my denominator can't equal 0. So if I just rearrange this like in its equation, it means x can't equal 3. So I just go over to my x-axis and I say, where's 3? Okay, it's there. My graph can't touch that. So if I were to do, let's call that 1. If I did another example, I said this was going to be quick, it's only 3 minutes. Let's do another example. Let's say I want to graph y equals 3 on, I don't know, x plus 0.7, and I was like, what the hell does that look like? Well, there's a really easy way of doing it, and it's, okay, let's let the denominator equal 0. So x plus 0.7, let's make that equal 0. Well, I know that that can't happen. So now I rearrange and I take away 0.7 from both sides, and that's where my asymptote is going to be. So that is my asymptote. And then if I want to draw it, I just go boom, boom, asymptote at negative 0.7, so that's there. Let's call that negative 0.7. And then, okay, this whole thing's positive, so that means I'm sitting here and here, so I just draw my graph like that and like that. That's terrible. Then I'm like, oh my god, it's even worse. And I'm not, even though this looks, that's y, that's x. So that's a quick way of thinking about where your asymptotes are, and that's why we don't have asymptotes. I thought that was something I probably should have said last video.